Hello everyone, good morning. Do you have any questions? Okay. So today we are going to talk about confidence interval, chapter 16. Okay, so what we did in previous chapter, we talked about X bar, sample mean, and we were able to use central limit theorem, explained a distribution for X bar, and then use that distribution to solve some probability question. Okay, so all the purpose of having a sample is to make a conclusion about population. Population is much bigger. Sample is part of a population. And then we talked about simple random sample to be the best sample because it's randomly chosen. Individuals are randomly chosen to be in the sample. And we want to now use all the information we had so far to kind of make a conclusion about information in population. So if you remember, we had parameter and a statistic. Parameter was any information that comes from population, right? Like mu, sigma, and then a statistic was the information comes from sample, like X bar S, correct? And then law of large numbers said, if we increase the sample size, X bar gets closer and closer to mu. So now we want to use the information so far we had, everything we learned so far, to find mu, find population mean, using X bar and the rest of information we have. In chapter 16, we will use all the information to give a boundary for mu, kind of interval for mu. For example, we will say mu is between this number and this number, possibly. And in chapter 17, we are going to make a question or make a claim about this mu, and then either we will reject the claim or cannot reject the claim. So in this chapter, we are just going to give estimate for mu using this boundary. We call this boundary a confidence interval. So a C% confidence interval for mu, and as you know, mu is population mean, right? Is estimate plus and minus margin of error. So when I say plus and minus, means I'm talking about a boundary that has estimate minus margin of error. I'm going to show that with ME. And then the upper boundary is estimate plus margin of error. So these things I wrote down here is exact same as this one. Lower boundary, upper boundary, and this is the interval. Okay, and then step by step I will explain what is this estimate, what is the margin of error. But before we are even able to use all this method to find a confidence interval for mu, population mean, we should know 3 conditions. If we don't follow these conditions or assumptions, we are not able to use this method. But in this class, most of our examples or questions are following these assumptions. But this is something in reality when we want to work on a real data, we should follow this. So it says, simple condition for inference about mean, means mu. We have an SRS from the population of interest, means we should have a simple random sample of size n from the population. And then it says there is no non-response or other practical difficulty. The population is large compared to the size of sample. Most of the times we say at least 20 times as large as sample. So population should be at least 20 times as large as sample. Then it says the variable we measure has an exactly normal distribution of mu and sigma. So the population should follow a normal distribution with a mean mu, a standard deviation sigma. And then the next part will explain and say that this mu is unknown, but the sigma is known. So of course mu is unknown, that's why we are trying to find the estimate for that, correct? And then sigma is known. Sigma is the standard deviation of population, right? I mean, in reality, it is so difficult to find the sigma. Even though we have some sigma and it's known, but still, this is assumption. And they say, okay, we assume that sigma is this, let's find mu, which is unknown. So in reality, we never can find sigma if our population is so big. So these are the assumptions that we should follow before we are able to even use this method to find a confidence interval for mu. So all the purpose in this chapter and next chapter is to find the estimate for mu, to find the estimate for population mean. So now, in this chapter, we are going to use a 3% confidence interval and find the interval for mu. This interval has a lower boundary, upper boundary. Let's say we are following all the conditions and everything is good. Okay? So now, this estimate is X bar, because X bar is a kind of estimate for mu. Minus margin of error plus margin of error. So, margin of error has a formula. Z star. Z we know, Z is Z value, a standardized value for X, right? Multiplies to sigma, which is a standard deviation of population, divide by a square root of n. This is the margin of error. So we are going to use and talk about this a lot. So this is a really important formula. What is that? Margin of error equal to Z star multiplied to sigma divided by a square root of n. So we call this margin of error. Okay, so now I'm going to replace this one here. So the lower boundary now becomes Z star multiplies to sigma over square root of n. The upper boundary is Z star sigma over square root of n. So obviously we know what is X bar, what is sigma, we know what is n. N is sample size, correct? The only thing maybe there's a kind of confusion is the Z star. So Z star is the Z value, but this is a kind of specific Z value for that confidence interval. So there are actually table C. The C you see here is the level of confidence. So you can write this down. C is the level of confidence. Level of confidence tells us how confident we are to find this boundary for mu. How confident we are that we are capturing mu between two numbers. Okay, so table C, is that table C? Yes, here, table C. Table C shows you all this boundary you want. All this, confidence level you need. Okay, so as you see, in top part of table C, it says confidence level C. So now we know C is the confidence level. In table C, we have the confidence level 50%, 60%, 70%, up to 99.9%. Here, for each of these C level, we have a Z star. So for example, for 50%, the Z star will be 0.674. For example, 95% confidence interval, Z will be 1.960. For 99%, Z is 2.576. So for any confidence level, we can have a Z star. For example, if I tell you, find the 96% confidence interval for mu, you are going to replace this Z star with which one? This number, 2.054. So as soon as you know the confidence level, you are able to find a Z star for that. So in this class, especially in your exam, there are some certain confidence intervals, level of confidence that we are interested in. And for your exam, I'm going to provide this in your exam, a part of your exam, in that table. So 90% is important, 95% is important, 99% level of confidence is important. And for each of them, there are Z star there. But in case you cannot find the Z star, you can go to the table C and find the Z star for any different confidence level. And there are actually some situations, even the table cannot give you the Z star for the confidence level you want. And there are some methods we are going to talk about, and you will learn how to find a kind of Z star for any different confidence level. Okay. Now, let's look at the example and then use this example and apply those formula to see if we are able to find a confidence interval for mu, population mean. And also we should interpret the interval, confidence interval, correct? So we are going to use this example. So the example says, a simple random sample of 20 cars in the drive-thru of a popular fast food restaurant had an average bill of 18.21 per cup. Okay, so first of all, we have a simple random sample of size 20, correct? Small n is 20. Then we have X bar for this sample, correct? So whatever information comes from sample is a statistic. X bar comes from sample. S comes from sample. So it says suppose the distribution of the drive-thru bill is distributed normally. So this was the other condition. We should have a normal distribution for population, correct? So we had already simple random sample. Now the distribution is normal too. With a standard deviation sigma, which is known for us, correct? This was another condition. And then mu is unknown for us. Means average of this population drive-thru bill is unknown for us. We want to see on average how much is the drive-thru bill. Okay. So let me just write this down. C%. Instead of confidence interval, I will write down CI. C for confidence, I for interval, okay? For mu is X bar plus and minus Z star sigma over square root of it. So we are going to use this formula. In this question, n is 20, X bar, which is sample mean, is 18.21. Sigma is 5.89. Okay. And then it says construct a 95% confidence interval. Level of confidence is 95%. Okay. So for this level of confidence, 95%, as you see, there is a Z star in that table, which is 1.960. Okay. So we are going to find a confidence interval, 95% confidence interval for this mu. Mu is the mid number, middle of these two. We have a lower boundary, we have an upper boundary, okay? And then we replace all the numbers we have. And then we are able to find a boundary for mu. So this says mu is greater than this one, this number here you will find. And then this one says mu is less than this number. So means mu is between these two, correct? Do you understand the math, kind of less than, greater than? Okay. So let's replace them. For X bar, we'll write down 18.21 minus. Z star is 1.960, right? Sigma is this much. Square root of 20. Mu less than 18.21 plus 1.96, 5.89 divided by the square root of 20. And as you know, this part is margin of error, and it will be exact same as this one. These two are the same. So if you find one, you are able to replace it for the other side. Correct? So the first thing you will do is to find the margin of error. What is the margin of error?
2.58.
2.58. 2.5. 2.5. So 20.79. Oh, sorry. This side is 20.79. What is this one?
15.63.
So the number you see here is in dollar. So this much bill. So this one is population mean. And whenever we want to interpret confidence interval, most of the time, we call this true mean of population. So this population mean, this true mean, is between two numbers, between 15.63 to 20.79. So we kind of found a kind of estimate for population mean, and we call this confidence interval. So now how to interpret this? We will say, so the level of confidence was 95%, right? We say we are 95% confident that we can, let's say we can capture mu, or instead of mu, you can say true mean. Or you can say population mean, right? Between $15.63 to $20.79. So we found the confidence interval for the average drive-through bill per car, correct? And this average drive-through bill will be between two numbers, 15.63 and 20.79. This is the way we interpret the confidence interval. Or you can say we are 95% confident that the average drive-through bill per car is between those two numbers. Correct? So you can just replace this average drive-through bill for mu, or you can say true mean, or you can say population mean. All of them are correct. As long as you are talking about how much confident you are, and you state you are capturing mu, and then you are stating these two numbers. Or also, there is another way of explaining confidence interval. You can say we are this much confident that mu falls between these two numbers. Okay, so there are different ways of, kind of explaining confidence interval. There are three important parts: this one, and this one. Okay.
Is that explaining the interval?
Yes.
For part B?
Exactly. Part B. So now we know what is the formula for margin of error. Let's use this formula and find some other kind of important thing. Margin of error is equal to Z star multiply sigma over square root of n. This is a formula, right? So in Math 120, if you remember, we can rearrange a formula and solve it for a specific variable. Like if I tell you, rearrange this to solve it for n, so what you do, you will isolate n on one side and the rest of things goes to the other side. Okay? So if you rearrange this, the first thing you will do is multiply both sides to radical n. If I ask you to solve for n, which is our aim now. So you're multiplying both sides by radical n. So you will get rid of this denominator, but on the other side you will have radical n multiplies to me equal to Z star multiplies to sigma. Right? Then you are going to isolate radical n. So you are dividing both sides by? Exactly. So you will divide both sides by margin of error. So on this side you will get rid of margin of error. On the other side you will have Z star sigma over margin of error. Right? Okay? Am I done? I'm solving for n, right? So what is the last step?
Square.
Exactly. We will square both sides. So this becomes n equal to Z star sigma over margin of error power 2. Okay? And this will be the formula for the sample size. So we can find sample size for any margin of error. Any margin of error. And here we are going to use this formula to answer part C. It says, how many drive-through cars, drive-through cars must be sampled if we want to estimate the mean bill per car within a margin of error of plus and minus $1.10. So plus and minus will be this one. So it's just showing that we have margin of error on both sides, okay? So you can easily ignore that, but the margin of error itself will be 1.10. Okay? So now we have the margin of error. From the previous part, we have the sigma. What was the sigma? 5.89, because they didn't change anything, right? And then let's see. confidence level is still 95% like before. So this one also didn't change. So for that confidence level 95%, Z star is 1.96. We already had it. So you have this information. Z star, sigma. Oh, sorry. This was margin of error. And Z star. You have 3 of them, correct? So what you do, you just replace all of them in this formula, correct? To find sample size for this margin of error. So sample size will go through. C star is 1.96. 9. Margin of error is 1.10. Don't forget the square of this parenthesis. Okay. What is this numerator? What is the numerator? 11.54. Okay. Now divide this. 10.49 power 2 110.14. Okay, I need this to explain something. Okay. Did you all get this number?
Yes.
Okay. This is a sample size, correct? It says we need this many cars to be able to estimate the mean build car within a margin of error of 1.10 with 95% confidence interval, okay? So this is sample size. So as you see, we have some decimal there. If you want to use rounding method, what you do, you just get rid of that part because it's just a small number, right? It's lower than 5 and you get rid of that, correct?
Yes.
But when we are talking about sample size, we are not going to do that. Instead, whatever numbers we have after decimal, we are going to round up our sample size. So this number becomes 111. Exactly.
So
Do you understand this?
Regardless of
Yeah.
if it's.
So we just round up even if there's like 0.01 decimal.
Exactly. Whatever you have, you are going to round it up,
Okay.
no matter what.
Gotcha.
If the decimal number, the decimal is so small or whatever, you would round it up.
Rounded up just by 1?
By 1, just by 1. Unless you have a kind of exact number, exact integer. Unless you have an exact integer, like your result was 110, you wouldn't do anything. But if you have any decimal after that, you have to round it up by 1 digit. Okay? So we need 111 cars to be able to estimate the mean drive build through. Do you have any question?
Are we gonna do problems where they don't give us like the exact percent? Like whether it's will we see problems where it's not 90, 95, or 99%. Say it's like within 85%, whatever.
So we will have a problem that gives us some confidence interval, for example, confidence level C, that we even cannot find the Z star for that in this table. So look, in this table we have 50% confidence level up to 99.9%, but some of them are missing. So for example, we don't have any confidence level like 93%, 92%. Correct? You don't see that. So I'm not going to talk about that, talk about this kind of things this section. Next lecture we are going to, solve more kind of complicated problem in different situation what we are going to do. But this time today we are just going to solve these simple problems and kind of, be familiar to some basic of confidence interval. Okay? Yes, next time we are going to definitely talk about that. So now I want to show you where is that? Okay, so the concept of confidence interval. Look at this picture. So first of all, there is a relation between did we talk about alpha ever? We didn't talk about alpha, huh?
No.
The next section, the next lecture, next chapter we are going to talk about. Okay, so next chapter I'm going to compare alpha and 1 minus. Okay, so now look at this. This area you see under normal distribution, this gives us a boundary for confidence interval. Like our confidence interval will be a boundary like this dark blue, either shifting to this side, but now just imagine it's a symmetric. Like we have this boundary here, whatever we have area on this side is exact same as whatever area we have on the other side. So whenever we are talking about some confidence interval that we don't have in table C, we are going to use this kind of picture to imagine and understand everything better to be able to find the Z star for those kind of confidence interval that we don't see in table C. So this is an important picture. I'm going to use this next time when we are going to talk about those kind of confidence interval. Okay, so now more questions. So next time I will go through this one too. This is important. Okay, so now let's just solve more questions. Okay, here. This one. And this is the question we are going to solve next time, this part of the question. But now, today, we are just going to solve all this. Okay? Please write this down. Try your best to answer this question using the formula. Okay? And I will give you 10 to 15 minutes. Figure this out. Let me bring the tape that a small table for you here. Okay. So now you can use this table. Okay? Isn't that? It's just one question. A, B. Look, A is just finding confidence interval, B is just interpreting confidence interval. Okay? And then C is finding the sample size. Three. Okay. Are you done? Done. Okay. So before I solve this problem, I forgot to talk about something. In previous question, in first step, when we found the margin of error, what was that? 2 point something? Can you look at that? Huh? First part.
2.58.
5A. Okay. So look at this. With this margin of error, 2.58, we had how many cars? 20 cars. The sample size at first was 20, right? When we decreased the margin of error to almost less than half, I mean more than half. So what happened? We have 1.10 now, and then all of a sudden our sample size increased, right? It's not 20 anymore. It's 111 cars. Do you see that, the difference?
Yes.
So when margin of error was bigger, sample size was small. But now when margin of error is smaller, sample size is bigger. So next time, or if I have time today, I will talk about this relation with you. Yes?
How, like, when it says plus or minus 1.10, or like, and this one says plus or minus 0.1, how do we know that it's plus or minus? Like, I don't know the most part.
So when it says plus or minus, it's mentioning this part. So this is the plus and minus it's talking about. You can easily ignore it. Because if you even put that in parentheses square 2, you still will get positive, right? Either plus or minus. Either of them give you the same result, right? Because we have this in a square, in a square. That's why. So it doesn't matter which one you are using, because either of them give you the correct answer and the right answer. Both will be the same. Okay, so in this question, it says, suppose a college enrollment manager takes a simple random sample of 100. So the first condition applied. We have a simple random sample of size n, right? It says of the college student and calculate their age, average age to be, average is X bar, right? Because it's in the sample of size 100, so we have X bar here, 20.7 years. It says suppose the age of all the college students are normally distributed with a standard deviation. So the second condition, population is normal. And then the third condition, sigma is known. We have this sigma. Okay. And now it says construct a 90% confidence interval. Level of confidence is 90%. For this level of confidence, from the table we can find Z star, which is 645. Correct? So we have all the information we need. Using the formula for confidence interval, X bar plus minus C star sigma over square root of n, we have 20.7 plus and minus 1.645 multiplies to 2.5 divided by a square of 100 is a square root of 100 is 10. So 20.7 plus and minus. So have you calculated margin of error?
Yeah.
What is that? 112. Okay. So now let's say 0.4.
Yeah. Yes, 0.4.
No, or yes.
After you divide it,
After you divide by 100,
by
a square root of 100,
it'll be
it will be 0.4, right?
Yeah.
So this one goes here, and then U, then 20.7 plus 0.4, and then 2,
Oh, never mind. It's just
right?
Yes.
41.
because it changed.
Correct? So subtract this, you will have
20.29.
20.29.
20. Oh, it says to round to one decimal place.
Oh, 1%.
So it'll be like 20.3.
3.
Yeah.
And then 21.
21.1. Okay, so these are years, right? So the population mean will be between these two numbers.
So the rule for C doesn't apply for that, like, as, like, for, rounding? 'Cause you said if there's a decimal, you just round up, or that doesn't apply to that?
Oh,
That's for sample.
that
sample size.
that one is for samples.
Okay, yeah, that is just
That one is.
cool.
So the age is between these two, correct? So now let's interpret this. We are 90% confident that the average age of college student. So I'm interpreting in different ways. So you learn how to, explain it in your own word. So the average age of college student falls between 20.3 years old and 21.1. Yeah.
We kind of run that test if we put just mu instead of college age.
Yes, you can do that. Yes, you can say mu is between these two numbers. Or true mean is mostly, they call that true mean between these two numbers. So now we have, I want to keep the margin of error and compare with sample size. So our margin of error is 0.4112. Okay. And this was the sample size for that, right? Okay, so now let's solve C, which it says how many college students must the manager sample if she wants to estimate the mean age of the college student within a margin of error 0.1 year with 90% confidence. So always be careful. 90% didn't change, right? So we have the same Z stuff. N is equal to Z star, this one, N is equal to Z star is the same. Am I right? Multiplies to 2.5, divide by, what was that? 0.1. Lesson.
41.
Lesson, please. What is this?
Oh, right.
41.5.
After or what?
That's
125.
that's still you have to divide. Square it.
That's
It's
the
not
40
the
square.
final
125.
125.
No, 41.125.
I got it. Correct? Square this one.
1691. 126.
1619.
1691.
Oh, 91.
0.26. And you round up to 1,692.
1,692
Students.
students. Exactly. Good. correct? So you see that the sample size was just 100. Margin of error was 0.411. Now the margin of error changed to much smaller, 0.1. The sample size increased. How many times?
Like 10
A lot.
times more.
A lot. Okay. So do you get this?
Yes.
Do you understand this?
Yes.
So now let me, if I have time, I want to talk about, okay. Let me talk about the margin of error. Sorry. Okay, so listen to this. So we have a formula for margin of error. Margin of error is equal to z star sigma over square root of n. I want to see how changing the margin of error will change everything. Okay, first I should explain this. Let's say I have two confidence intervals. Okay, so this is a kind of format of confidence interval when it says estimate plus and minus margin of error, right? If you want to talk about, which one is margin of error, you say, okay, here in this confidence interval, this one is margin of error. Here in this one, 10 is margin of error. And as you see, estimates are fixed. Correct? So we have two confidence interval. Estimates are fixed. Let's call this I1, this one I2. Interval 1, interval 2. Okay? So now I want to see which one I like more. So if I say mu falls between these two numbers in this confidence interval, means mu is the number between what? 23, 27. If I want to say mu falls between two numbers, here mu is between 14 or 15?
14.
10. It's 10.
Yeah, 14 or 15. Oh, that was 11.
10. I said margin of error is the same.
Yeah, I know, it was like 14 or
15
Yeah, 15.
and 35.
Oh, yeah.
Correct?
Now I'm confused.
If you see this kind of interval and compare it with this one, mu falls between these two numbers here and mu falls between these two numbers here. Which one you prefer? Why?
The first.
Like smaller than the closest.
Correct? So which one you prefer? The first one. Why? Because it's easier to say where is mu exactly. Which one is mu? Either 24, 25, 26. You have just three numbers, right? So mu can be either of these three numbers. But what happens here? So many numbers. Many numbers, and mu can be any of these. So you prefer this one. And this, as you said, is a smaller confidence interval. So most of the times, almost all the time, we want a smaller confidence interval. Correct? We want a smaller confidence interval. So this was a smaller confidence interval. In this confidence interval, a smaller confidence interval had a smaller margin of error. Do you see that?
Yes.
So if we want a smaller confidence interval, we want a smaller margin of error, right? So if we have a formula for margin of error like this, what to do to decrease the margin of error to reach our goal to have a smaller confidence interval. So now, I want to see what to do with this to have a smaller margin of error, because we want a smaller margin of error to reach a smaller confidence interval. So, this means I want to decrease this. If I want to decrease this is a fraction. This number is not proportional to this one. Means increasing this one will decrease this one. Okay? Decreasing this one will increase this one because this is in denominator and they are like inversely proportional. Right? But this number here is directly proportional to whatever we have on numerator. Do you understand this? It's kind of math. So if I want to decrease the margin of error, I should decrease Z star, right? If I want to decrease margin of error, I should decrease a standard deviation. If I want to decrease margin of error, what should I do to N, sample size?
Increases.
That's why when we had a smaller margin of error in third part of each question, all of a sudden sample size was so big. So this is the relation. So smaller margin of error, we want to increase sample size N. Correct? A smaller margin of error, we want to decrease which one? Z star, right? Because Z star is in top part. Proportional, right? To have a smaller margin of error, what should we do to sigma? Decrease standard deviation. Correct?
Yes.
So we want to have a smaller margin of error. These two should decrease. We want to have a smaller margin of error. This one should increase. So now we want to continue this one. Decreasing Z star. This is the last part. How we can decrease the Z star? Look at table. So Z star is smaller here and increasing to this side, right? For a smaller Z star, we have a smaller confidence level. For bigger Z star, we have a bigger confidence level, right? So if you want a smaller Z star, we should have a smaller confidence level, okay? Okay, do you understand this? Do you have any question? No question? Okay, so next time we will continue this chapter, more question, and I have some more stuff. If you don't have, for example, a confidence level showing here what to do and all of this. Okay, so we'll see you on Monday if you don't have any questions. We are done now. 3 minutes left. But if you have any question, you can ask me.